Hi guys, welcome to my video. Today we're going to be talking about physical quantities and units for A-level. We'll first start off by looking at the Cambridge syllabus as well as the Zimsec syllabus. For the Cambridge syllabus, we're asked to understand that all physical quantities consist of a numerical magnitude as well as a unit. And we're also going to record the following SI-based units, which is mass, length, time, current, and temperature. We're also going to express derived units as products and or quotients of SI-based units, as well as use those derived units for quantities. The rest are involving homogeneity, prefixes. We're going to cover them in future videos. For the Zimsec syllabus, it's still the same. We're going to express derived units as products or quotient of base units, and we're going to use the named units listed in the appendix, which we have stated above, which is mass, temperature, time, etc. So we'll first start off by defining a physical quantity. So when you say physical quantity, it is a measurable aspect of matter that consists of a numerical magnitude and a unit. So if anything has a magnitude and if anything has an acceptable unit, we term that a physical quantity, and it should be measurable. For example, mass. We can measure mass. The unit is the kg, and the magnitude can be anything, 10, 20, 30, any number. It is termed as the magnitude, and the unit is the SI unit, which is acceptable everywhere. So physical quantities are classified into two types. We have base quantities. A base quantity is a quantity that is independent of other quantities and cannot be expressed in the simplest form. So it's the simplest quantity that you ever get. For example, time. Time cannot be expressed in any other form. So time is termed a base quantity. And a base unit derived form. Examples of base quantities are given below. We have length, which is in meter. The mass is the kilogram. The temperature is the Kelvin. For time is the second. For current is the ampere. For amount of substance is the mole. And the symbols are given in the third column. Right? So to fully understand this table, you can use the following acronym, which is very easy. It is known as MAX, right? And this will save a lot of time in your exams. So it is known as marks, and by using this acronym, you get all your marks in your exams. Exactly. So the first M stands for meter, right? So meter is for length. The next M stands for mole, which is for amount of substance. The A stands for ampere, which is for current. The K stands for Kelvin, which is for temperature. The other K stands for kilogram, which is for mass. The S stands for second, which is for time. So SI units are the fundamental units. So the main advantage is they have the same meaning everywhere in the world. And then when we say derived quantities, we are expressing base quantities as either products or quotients, right? We can never add or subtract to get derived quantities. Why is that? For example, if you say 4 kgs plus 4 kgs, you get 8 kgs. You have not changed anything. The unit is still the same. What is only different is that the magnitude is bigger, but the unit is the same. But if you say 4 meters times 4 meters, you get 16 square meters, right? That you have transformed from just length to area by simply multiplying length. So as long as you multiply or you divide base quantities, you're always going to end up with what? With derived quantities. A derived unit is just an express product or quotient of base units, right? A given example is as follows. A brick is like a base quantity, right? It is the basic building block of a house. So a house is built up of bricks. So bricks are like base quantities. They make up a house. So a house is a derived quantity that is made up of what? Of bricks, right? So bricks are sort of acting like the base quantity. A certain combination of the bricks will result in a certain type of a house. So a certain combination of base quantities will result in a certain type of derived quantities. For example, if we combine length and time, we end up with what? With velocity. Some common examples of derived quantities are given below. These are the most highly examinable quantities, but under exam questions, you might be asked to derive for other quantities. What is important is to know the relationship and you can be able to derive. The first one is acceleration. Acceleration is mainly velocity over time. So if you say what are the units of velocity? Meters per second. So in our table, we have four columns, one for derived quantities, one for the formula, and one for the base units, and one for the special name. So for acceleration, it's very easy. So to get the base units, you just say, what is the units of velocity? Meters per second. The units of time, second. You divide the two, you get meters per second. For force, we know the relationship relating force and acceleration, right? So force is equals to mass times acceleration. The units of acceleration, we have just derived them above. For mass is the kg. So if you multiply those units for acceleration by the kg, you get kg meters per second. And some are asking, why are there square brackets? Well, those square brackets refer to base units of force. When it comes to that part, we move on to work done. So work done is equals to force times displacement. So we have the units of force multiplied by the displacement, and we end up with what? With the units for work done. The special name is the joule. For power, power is work done over time taken. The work done, we've derived the units above, which is kg m squared s to the power of -2. And then if you divide by s, and you just apply the laws of indices, the s is raised to the power of 1. So if you say -2 minus 1, you get s to the power of -3, which is the units of power, which is kg m squared s to the power of -3. That's the special unit for power. The units of power is the watt. For pressure, pressure is force over area. So if you divide force by area, you end up with the units for pressure, which is the Pascal. For voltage, this is a very, very important one. The formula for the relationship, rather, relating voltage and work done is voltage is equals to work done over charge, right? But charge is equals to current times time. The units for work done, we've already derived them. Since voltage is the work done per unit charge, if we derive the units for work done over the units for charge, we end up with the units for voltage, and the special name is known as the volt. For kinetic energy is the same. You multiply the units for mass and you multiply the units for the velocity, but you square that and you end up with the unit for kinetic energy. For frequency, it's still the same, 1 over time, so it's 1 over s, and you get per second, which is the units for frequency. For resistance, resistance is equals to voltage over current. So the units for voltage, we've derived them above over the units for current, and the rest you just apply laws of indices to get kg m squared s to the power of -3, a to the power of -2. The special name is known as the ohm. For momentum, momentum is equals to mass times velocity. So the units for momentum are just kg meters per second. So these certain objectives that we've just completed about deriving base units is very, very important, because the examinations just give you any relationship and you must be able to derive the units of any given quantity in that equation. So you don't necessarily have to know the relationship, and you're going to see this in future videos that we're going to cover. Looking at past papers, that you don't necessarily have to know the relationship, but if you just know the fundamentals, the units for resistance, momentum, voltage, the units for force, they will help you to tackle various different questions, and they're going to be very easy. But what you should know are the basic What is important, remember, do not forget those square brackets. You must maintain this law throughout the whole process as you derive your base units, otherwise you lose marks, right? It is termed as wrong physics. So by leaving those units, you must always make sure that you always put them. If you leave them, you lose marks, right? So in our next video, we're going to be talking about reasonable estimates of physical quantities that are included in the syllabus. So this is a very, very tricky objective, but I'm going to try my best to easily explain this objective and give you some of the highly examinable estimates that have come in recent papers and how you can tackle them in the future.